In Chapter 16, we're going to look at what's called acid-base titrations, and we're going to look in 16.1 at the concept of pH, and we'll look at what's called pOH and how to calculate those things. The first thing we need to be familiar with is called the self-ionization of water. When you have a water solution, you're going to have water molecules, and those are going to be breaking apart into ions and reforming back and forth as H3O hydronium and hydroxide. So a hydrogen ion may come off of one and move to the other. And these are all going to be mixed in evenly in a container of pure water. So again, the hydrogen ion H plus off of one water will move to the other, making H3O positive and leaving the one where the hydrogen ion was removed being OH negative, hydronium and hydroxide. The concentrations of hydronium and hydroxide in pure water are going to be equal, and they're going to be 1 times 10 to the negative 7th moles per liter at 25 degrees Celsius. When we have the brackets around these formulas, that means the concentration of something. So we're looking at concentration of hydronium ions and then concentration of hydroxide ions. K sub W is called the ionization constant for water, and this is a constant number. It doesn't change. So the ionization constant of pure water is going to be when you multiply the hydronium concentration times the hydroxide concentration, you will always get 1 times 10 to the negative 14 molar. Any solution that is neutral, you will have an equal number of hydronium and hydroxide ions. If the solution is acidic, you will have more hydronium, and if it's basic, you will have more hydroxide. Any solution where the concentration of hydronium is greater than 1 times 10 to the negative 7th, you will have an acidic solution. And if the hydroxide is greater than 1 times 10 to the negative 7th, the solution is basic. So how can we calculate those concentrations? Well, we're going to keep in mind that those hydronium and hydroxide concentrations multiplied together always equal 1 times 10 to the negative 14th. So if we are given one of the concentrations, we can easily solve for the other by taking our 1 times 10 to the negative 14th and dividing by the one that we're given. So let's say that we have hydronium and its concentration is 1 times 10 to the negative 6. We want to find hydroxide. So we're going to take 1 times 10 to the negative 14th divided by our 1 times 10 to the negative 6. And again, make sure you use parentheses when you're dividing. And that's going to tell us that the hydroxide concentration is 1 times 10 to the negative 8. One little kind of tip, if you are just dealing with numbers that are all 1 times 10 to the something, 1 times 10 to the exponent, the exponents of your hydronium and hydroxide added together are going to equal your negative 14. If you're dealing with something other than 1, that won't always be the case. Now if we look at pH, this is a French word, which basically means hydrogen power. And so you've probably learned about pH before, and it's going to tell you how acidic or basic something is. But really, it's determined off of the concentration of your hydronium ions. And we're going to use this formula below to figure out pH. So it's the negative log of your hydronium concentration. And so here is a pH scale with several different substances so we can kind of see. Pure water should be neutral. Things like baking soda, ammonia, drain cleaner, higher than 7, those are basic. Things that are lower than 7 are going to be acidic. So we can see vinegar, tomato, lemon, hydrochloric acid. pOH is looking at the concentration of hydroxide ions. So if we have pOH, we're going to take the negative log of the hydroxide concentration, and that will give us pOH. The pH and the pOH are always going to add to 14. So if I know the pH, I can take 14 minus my pH to solve for my pOH. Neutral, both numbers will be 7. Acidic, my pH is going to be less than 7, and my pOH will be greater than 7. But the basic solutions, pH is going to be greater than 7, and pOH would be less than 7. So they're flipped. If we know that the pH is 3, then the pOH is going to be 11 because pH plus pOH always equals 14. If we are given the pOH of 2.7, then the pH is going to be 14 minus 2.7, or 11.3. Now, being given all of these different equations, we can calculate concentration of hydronium or hydroxide if we're given pH, or maybe if we were given pOH. So let's say that the pOH is 3. We can find our pH by taking 14 minus 3. So we know our pH is 3, or is 11. So then, to find our hydronium concentration, 11 is going to equal the negative log of our hydronium concentration. So to solve the log, the opposite of log is an exponent, basically. So you would type in 10 to the negative 11th, and that's what we end up with. If we know that the hydronium concentration is 1 times 10 to the negative 11th, we could find our hydroxide concentration by taking our 1 times 10 to the negative 14th divided by our 1 times 10 to the negative 11th and get our hydroxide. Or we knew that the pOH was 3, so we could say 3 equals the negative log of the hydroxide concentration. So that would be 10 to the negative third, or 1 times 10 to the negative third. And so we'll be looking at lots of these problems over the next few days.